Hey everybody, this is Ming from Singularity Engineering. Today I'll be doing a demonstration of a press fit or shrink fits problem. So press fit problems involve squeezing typically a soft material into a hard material. So we're going to go with polyethylene here and structural steel. This is often used to hold a piece of material in place and give it some support. And simulating this effectively requires a nonlinear contact simulation. So I'm going to give a quick example of how that's done in ANSYS Workbench. So I'm going to start by creating the geometry. Let's do a 20 millimeter pipe by 22. We'll make it about this long, and I'll call this one the pipe. The interior part, we'll pull on this, maybe not quite as far, and we'll call this one the insert. Okay, so if we just do a solid insert, it's kind of boring, so we can put some changes on this model. So let's cut a hole into it. And we will add in some fillets to relieve the stress that develops in these corners. That looks about right. And now we can imagine that this as a symmetric model. The key thing here is that as the insert gets squeezed, it'll tend to try to bow out of the structure of the steel sleeve, and that could, if there's very fast contact status change between the two, it's not, it could be difficult to converge. We would have to do some additional contact settings here, and I'll show you how that's done. So let's go ahead and run the static structural simulation. All right, here's a model, and we'll move our way down here. So the pipe will be steel, the insert will be polyethylene. There's a contact that's been detected automatically. So right now the two parts are meeting exactly aligned. Typically what I like to do is actually model in the press fit. So you want to model both parts as um, um, as their uh, build shape. So let's change the radius by 0.1 millimeters. So we're actually modeling in the overlap. If I update the geometry, and look here, you can see the penetration. And now, because the penetration is fairly large, it removed the contact for us. But that's okay. We can select these two faces and define a frictional contact. Typically, I like to use frictional contact because obviously there's quite a bit of friction between these two materials. You can specify an actual friction coefficient if you have that data on hand. A quick generic mesh looks like this. So we want a little bit more refinement on the pipe. So there's a special meshing technique in ANSYS that recognizes cylinders like this and allows us to put 3 elements to the thickness of the cylinder. I want to make the mesh on our insert a little bit more refined too. So we can select this, put in a size, and maybe a 2 millimeter mesh. Okay, so it's still fairly coarse, but we can certainly refine it, especially if we're interested in the stress in these areas. This should definitely be further refined, but in the interest of time, we'll let this be. Let's put frictionless support on the bottom here. And so we want to turn on weak springs to prevent the entire assembly from sliding around. I can certainly cut this model into half or quarter symmetric models as well, That'll help to constrain it. This will be a large deflection analysis. Um, that turns on the nonlinear solution settings, and we want to have some steps. So we want to start with 10 steps, and we're going to go with, say, 10,000 steps. And this will gradually increment the loading. The only loading between the two parts right now is this interference. One of the key settings here is we want to change this interface treatment to add offset ramp effects. So initially it'll start with um, penetration, and it'll gradually zero out this penetration as we conclude the simulation. So that's all we need to do to set up this analysis. It's a nonlinear analysis, so this will take a few minutes to run, and we can monitor the force convergence under the solution information tab. All right, so the simulation is completed. It's taken a few minutes. We can take a look at the deformation. That's the exaggerated. This is the true result. So you can see that as the part, the interference here slowly shrinks until there's nothing left. We have deformation on both the insert as well as the pipe. We can exaggerate the deformation. You can see that the insert shrinks inwards and the pipe kind of expands outwards. And there's a little bit of rotation because I didn't constrain it completely. There's a lot of options for constraining these models. As I said, quarter or half symmetric would work really well on models like this. But sometimes I like to show the entire pipe for visualization purposes. We got the stress. You can see the amount of stress that develops due to the insert. There's stress on both the pipe as well as the insert. And we can look at things like fatigue or safety factor. Okay. So it looks like we have some failure of the insert. Again, the area of failure are in the corners where we'd expect. And to get accurate results, we probably want to mesh those areas a lot finer. So that's a quick example of what you can do with a quick nonlinear contact simulation in terms of modeling a press fit or shrink fit problem. We can do this a number of ways. We can cool this down, heat it up, move it around, and things like that. But this is a typical example of how this is done. So thanks for your watching this presentation, and have a good day. Bye bye.